teamed up with BRE and some other manufacturers, leading manufacturers in the industry, and I want you to tell us what you see on site. I need your help. SolarEdge needs your help. Everybody needs your help. Morning, everybody. It's 10 o'clock, so we'll start the presentation. What we're going to show you today is the bad and best practice for installing SolarEdge products. That doesn't mean you install them badly. I'm just showing you what we've collected, what field engineers have collected, what I've collected, what people have seen, SolarEdge people have seen while going to site, and hopefully we shouldn't see these mistakes again. And then the very last thing is the BRE survey, and I'll explain what that's about later on. So as usual, these are the team members for the UK. You probably recognise some of them. Hopefully you've spoken to all of them at one point or another. The only person you probably won't have spoken to will be Amy or maybe Yolandi, but the rest of us you can speak to. In 2017, there was a document produced by the BRE, and there's a link of it at the bottom, and I will put that in the chat at the end. I don't want you to look at it now, but I'll put it in the chat at the end. So there was a report, and basically they recommended that there were a few things that people needed to do to ensure that there were no solar PV fires or damage to properties or things like that. And the first one was design and installation. So design it correctly within the manufacturer's guidelines and the MCS guidelines and the IET guidelines, and then install it as per the IET guidelines, the MCS guidelines, and also the manufacturer's guidelines. And they recommended that the designs needed to be improved and the installation standards needed to be improved. They were pretty poor in 2017. This is what they discovered. They also discovered that DC isolators were a leading cause of PV fires, not because of the DC isolator. So let's make that quite clear. The DC isolator is a very good product on its own. It works incredibly well. If it's the wrong product chosen for the wrong device, if it's installed incorrectly, if it's full of water, if the cables are not tightened, there will be problems with it. And that is not the fault of the DC isolator. But the findings were that because installers couldn't do that correctly, that it was to remove the DC isolator. And you might see now that pretty much all inverters out there have no DC isolators. Now, SolarEdge is unique because we don't need one, because we have safe DC, so we can isolate the power, voltage, and current in a string to below safe levels where other people can't. Some inverter manufacturers are not even using plug and socket connections. So by that I mean an MC4 male and female. They're not using those. They're using a lever type of terminal. That isn't correct. You've got to have a DC isolator with a lever connection, because if you're replacing the inverter, you're going to pull out a bare cable, aren't you, through the gland, through the inverter, and that's not safe. The whole purpose of DC isolators is basically to turn the string off to allow you to remove the inverter. So with SolarEdge, as I said, it's not a problem. If you're using an inverter that has a electronic twist disconnector and it has a plug and socket, again, it's not a problem, but I would always advise using a DC isolator with those particular products, because if your MC4 comes apart, you then have a live cable. SolarEdge you don't, but others you do. And definitely if you're using an inverter that doesn't have plug and socket, because they will need a DC isolator. So then they looked at the recommendations to improve the standards and guidance. So it's 2025 now. We are, what, 8 years on, and we're going to see if these standards have actually done anything, if people have improved. So that's what we're going to show you later on. Then there was DC connectors, people using the wrong connectors, people not using the correct tools to crimp the cables in the connector. That was a major issue. They looked at improving the standards of guidance for them. Also inverters, where inverters could be installed, the spacing of them, how you would install them, whether you can put them inside, whether you can put them outside, and then maintenance, what's actually required to maintain your PV system afterwards. So if you have a PV system and it's covered in bird mess, well, that's not going to do very good. It's not going to produce very well. It's also going to cause some problems with hotspots on your panels as well. Likewise, if it's covered in leaves, or if it's facing the wrong directions and you are have too few panels in the wrong directions, it's also going to cause problems. That's not maintenance, that's design. But making sure your panels are clean, making sure that they are producing the best they can, that's definitely comes down to maintenance. And then what's required on the actual inverter. Solar edge inverters, the only maintenance you need to do is just to make sure the fans are clean. And the period for that depends on the environment you're in. So if it's a very dusty environment, more frequently than you normally would. If it's a normal installation, there's very low dust, once a year. I have my inverter for 5 years and I look at that fan periodically, but that doesn't need cleaning. It doesn't look dirty, it doesn't look blocked. And the last one was compliance with standards. So there are some new documentation that's come out, the IET Code of Practice for solar PV, grid connected. There's also the electrical energy storage systems, both from the IET. There's also a installer, a professional electrician EESS document from the IET. You've got a NAPIT document, you've got NCS documents. All these documents here are trying to force you to install it correctly. Okay, and let's see how people have done this installation. So here are some examples of poor installation practices. So these are things that we see when we go around, and one of the big problems is cables that are just left dangling over roof tiles. Now, this installation has got to last for 25 years, hasn't it? Because that's the modules, minimum of 25 years. You know, with Solar Edge, you can get the extended warranty. Your optimizers are 25 years, your modules are 25 years, and you can have the inverter for 25 years. That's no problem at all. Now, all this is great, but it's got to be installed correctly. What you can see on here is two things. First is you've got exposed cable. That can be a bit of a problem, especially if you are having things sitting on it, pulling on it, tugging against it, or just moving in the wind. These are very rough and abrasive tiles, and if you can imagine that cable swaying over 25 years, it's not going to be long before the actual cable itself, the insulation of the cable, is going to wear thin, leading to isolation issues, which will mean loss of performance, which again, you then think, well, it's got to be something wrong with the modules, it's got to be something wrong with the power optimizers, or it's the inverter, but it's not. It's a simple piece of cable, very cheap piece of cable that's just been weathered over time, abrased over the tiles over a period of time, and now has a hole in it. And as the rain falls down the tile, runs onto the cable, drips onto the connector, and then causes problems. So these are common things. And what would you do to resolve this? Well, simply support that cable, tie that cable in such a way, run it in a type of conduit, a flexible conduit, run it on a piece of tray, run it in a piece of trunking, anything you wish, just to make sure that cable is protected, mechanically protected. Yes, I understand that the Solar Flex in particular has insulation on there, but it doesn't mean that you should take that as the only thing you can do. And likewise with connectors, secure them in such a way that they're off the tile and also out of the elements, out of the rain. As you can see on here, the angle of this, the cable will literally drip down, or the rain will drip down that cable because of the angle, and it will settle against the connector. And then once it hits the connector, It will sit there for time, and then a period of time that will then gradually work its way into the connector, causing you problems. So again, poor entry-exit cable from loss space. You can see on here the cable's being dragged between the LED flashing and also the tile. It's not a great way to do it, because over time, when the wind blows, that tile's going to move, because all tiles are flexible. That's going to crush the cable and lead to isolation issues. So these are things that are nothing to do with the product. These are purely on installation. And then we've also got someone else has broke a tile. Rather than replacing the tile, they've just put a bit of material on there, maybe like a flashing, to stop that from causing a problem. But you know, these are things out there that happen on the roof that nobody really knows about. Next one, we've got vermin damage. So because the cables themselves are quite low, you can see in the middle picture that the copper is exposed. They're being chewed. People have been you know, come across these cables, touched the cables, got an electric shock because there's no insulation. The possibility also with the material underneath for starting a fire is quite high. So keep the cables supported, keep them away from anything combustible, and protect them. Just because they've got double insulating on doesn't mean that they need to be, they can be left there. They've got to be routed correctly. And on the right hand side, you can see a power optimizer just abandoned. That's being dragged across as the wind blows. So yeah, that's not helpful to anyone. We've also got some other damage here. So damage to cables. If you notice a piece of cable that's got damage on it, then replace it. Cut it off, put an MC4 on there, or replace the piece of cable. It's going to cause problems. You can see on this, the way that these pictures are taken, the water is just simply going to drip down onto these, go into that MC4 and cause it problems. And on the right hand side, you can see a coil of cable over there, just dangling over the roof, and the optimizers basically not being fixed, and that's slid down the roof. So again, that's not good. The optimizer, if it's in direct sunlight and it reaches 85 degrees, or the temperature inside it reaches 85 degrees, it will turn off. That's not a fault of the product that's designed to do that. It's a fault of the installation. This cable here, as you can see, was squashed completely under the module. You can actually see it's got a bit of copper on there where it was exposed. So that was shorting out, causing an isolation fault, possibly arcing as well. There'd be a parallel arc between the array and to the cable. Fortunately, because of solar edge and the arc fault detection, we can do series and parallel arcing detection, and we can stop. So it wouldn't have been a problem for us because of solar edge, but if it was a traditional system, that would have meant the system would be live. That would also meant that the good possibility that the roof itself would be live. So this is another reason why you would install solar edge. But again, this is not the manufacturer's fault. This is not the product's fault. This is installation issues. We've got MC4s, MC4s that haven't been connected correctly. So the one on the right hand side, you can see has some form of crimping, but that's just pulled straight off. I pulled that one off in my hand. Again, the beauty of solar edge, you turn the inverter off, you wait 5 minutes, it goes to safe DC, minimum of 50 for commercial, 50 volts commercial on a string, for residential 25 volts in a string. So I was able to give that a pull, and simply by pulling it, you hold the MC4, you hold the cable, you give it a slight tug. I don't mean I was doing my impression of Jeff Capes here. That's a very old reference, but I was not pulling for life. And it came apart, and this is one of the problems. The inverter wasn't working, the optimizers weren't working, and the reason it weren't working because of safe DC, because of the arc fault detection, because there was a very poor connection between the cable and the MC4, leading the inverter to fail. Again, that is seen as a product issue, but it's not a product issue, it's installation issues. So other MC4s actually at the inverter, pulled out completely. If you look at the two on the left, they look hardly as if they've been clamped at all. So all other MC4s are manufactured, obviously between the panel and the optimizer, and between optimizer to optimizer, they're all manufactured and tested. These are the man-made or person-made links, the flying leads from the array back to the inverter, and that's the weak point. Okay, thankfully, because it's solar edge, it detected there was an issue and it stopped. So I'm sure you know this, but these are the dimensions that we have around the optimizer. So if you look at it face on, you can see that there is 10 mil in all directions, the top, bottom, left and right. And if you look on the side view, you can see that we have 12.7 clearance above the optimizer and 0 before. Very simple rules. Not, you know, you could use your index finger as a 10 mil guide. That's pretty much roughly it. If you can get your index finger between anything on the top, bottom, left and right, that's perfect. And if you can get 2 fingers above your optimizer, that's perfect as well. The other thing to remember is the bending radius. Don't pull the cable, don't stretch the cable, don't pull it because you want to make sure that it's taut. You know, you've got to give it a good bending radius, you've got to allow the cable to flow as it naturally does, and you've got to secure it. And likewise, don't use an impact driver to install. Always use a drill that has a chuck on it and it's not an impact driver. If you're going to install optimizers, do that. It's pretty much, I would say, other than putting the bracket on the wall, there is no need for impact drivers in the insulation world these days. You can't use them for clamps on panels. You can't use them on putting optimizers on. So there's very little you can actually do with impact drivers these days. Likewise, don't leave the optimizers disconnected. If you connect them together, or you can use the seals that come with the inverter, you know, the plus and minus seals that you pull out for putting the MC4s, we sell those. And if you want some of those, I can give you the part number. All you need to do is email me. I put my email in the chat there. Don't leave the optimizers out in the rain. Cardboard is not waterproof. I'm sure you know this, but cardboard is not waterproof. Don't leave them out in the rain. We had a couple of sites that I went to see, and the optimizer had been left out from February till May. Not very good, and very unlikely that these optimizers unlikely the optimizers will fail, but it's increased by having them outside in the rain because of the moisture content. You can't get moisture inside a connector. As soon as you get moisture inside a connector, it will stay there forever. And it just moves with the capillary action up and down, and then it makes its way through the connections, causing issues with the connections, corrosion, and then makes its way to the circuit board, and then causes a corrosion there, and that stops the optimizer from working. Again, it's not a fault of the product, that's a fault of installation, okay? Don't drill through the brackets. The brackets have holes in, they have slots in, allowing you to do things. Do not modify the optimizers either. This here is an optimizer that has a cable on it, and that cable there was left out to the elements, and you can see how the corrosion has gone on there. That then causes poor communication. Because of the way that Solar Edge works, it stops it from working. Now I've got a question. Just let me have a look at the question. Yes, okay, let's go back to slide 14. I think you've picked up something that I didn't see. Yes, 1.25 centimeters clearance. So it is actually 10 mil. So it is 1 centimeter, not 1.25. Okay. So yeah, you can see on here that we've got some corrosion. That's because of moisture that's got inside, and it just causes issues with communication. The optimizer then shuts down. Quite simply, it's doing what it should be doing because it detects it as a communication arc issue and then turns off. So a couple of questions here. Can I connect an optimizer to a panel with an M4-ish connector? Well, no. It has to be compatible. It has to be like for like. So there are some products out there that are certificated to work with MC4s. Can you connect a MC4 to an Evo 2 connector? Absolutely you can. They're both the same manufacturer and they're both being tested. So if you have a connector that isn't an MC4, Staubli MC4, then you need to make sure that that other connector has documentation to say that it can be connected to an MC4, a Staubli MC4, and likewise Staubli MC4 must issue documentation to say that connector ABC is allowed to connect to it. Once you have that documentation, everything is fine. Okay, on the left-hand picture here, you can see that there's a puddle of water by the arrow. You'll also see that there is the MC4. So what's happened is the MC4 has been taken out of a connector and it's been tapped on the floor and the water has run out of it. This is what I'm saying, with moisture building up in the actual cable. It doesn't go anywhere because the MC4 is, or the connector is actually IP rated, so it won't let water in, therefore it's not going to let the water out. So this is a problem. If you've got water inside your MC4s, it's going to cause a problem with corrosion, and it's going to cause a problem with connection. The second picture on the left and the third picture from the left, or the two in the middle, you can both see the corrosion there. That's because of water. That's not because of anything else. That's just purely water corrosion in there that has affected the connections. And on the right hand side, you can see a cardboard box that has been left out to the elements. You can see that cardboard has gone slightly faded because it's been out in the sun. And then you can see that there's considerable water on top of that cardboard that has left the environment where the optimizer's in to be very damp and very wet. You wouldn't leave your modules outside in the rain because likewise you'll get moisture in the connections. So please don't leave the optimizers outside in the rain. You can lift them onto the roof, that's perfectly fine. Then just go and get yourself some tarpauling, tuck it all the way around it, make sure it's secure, and you can cover up the optimizers. That's no problem at all. Okay, cables plugged in together. You can see on here, you've got a couple of issues with the one on the right. So they're plugged in together, so that's correct while they're being installed. However, some installers do forget to unplug these. Then you've also got, let me just get the laser pointer working. And you've also got the symbol here. Oh, it hasn't worked. Why hasn't it worked? It's a pointer. The pointer. That laser pointer. Then you can see on here that the umbrella means put this cardboard under some protection. Okay. And then you've got connectors plugged in. So I don't think there's anything wrong with this one. Nothing wrong with that one. So a big tick there. Okay. Then we look at other things, and we can see on here that there's no gap here, so we should have 10mm gap here, 10mm gap here. Look at the way the cables are all being tucked under and connected and twisted, and bending radius on them as well. And likewise, you can see here, you can see the bending radius on this one, you can see the bending radius on that one, you can see this one. This is like someone grabbing hold of your ankles and pulling your legs apart, isn't it? It's not going to be very good and comfortable, that. You wouldn't like to sit like that for 5 minutes, so this has got to sit like that for 25 years. What's going to happen to that over 25 years? It's going to be a weak point. And again, it's not the product's fault, it's how it's been installed. Optimizers on the back of the panel. Remember, this optimizer here is for cooling. This part is for cooling. And the panel gets hot, the optimizer gets hot, turns off at 85 degrees. You'll be angry and shouting because it's not doing what it should be. It's not the product fault, it's how it's been installed. These are good ones. You can see you've got the 10mm gap here. You can look at the bending radiuses, maybe a little bit tight, but it's not pulling on the plastic on here. It looks a little bit tight, but it's not actually pulling on the plastic. And the way it's been installed is correct. So you've got your finger underneath, so that's perfect. This one here, clearly being pulled, the bending radius, that isn't going to last very well. the cable tied up and tangled here. Someone's given that a good tug to try and break it, and it hasn't worked. And then all the cables here, bending radius on the MC4s as well, remember, tied up, tucked away. That's not good either. You can't have loops. Loops are not good. You have to run the cable out in its entirety, not in a loop. So run the plus and the minus together. Twist them together is the best solution. On here, you can see that everything is secured. Reasonably good. I don't think there's a problem with that bending radius from here. That bending radius looks natural. So again, no problems there. This is one I found. You can see on here, optimizer's not fixed underneath the panels, just left dangling in the wind. You can see on the top picture, we've got quite a few issues with bending radius, cable trapped underneath here, cables blowing in the wind here, dragging on the roof. That will be aware of the insulation, and over time that will cause an isolation issue. Again, it's not the fault of the product, it's the fault of the installation. And a better picture here with some other optimizers, again, just dangling on the roof. I actually went to this site and I said it wasn't acceptable, and the installer, to be honest, in fairness to them, reinstalled all the optimizers. They put some 2-inch light gauge tray between, secured all the optimizers perfectly. And from this one site visit, which turned out to be a bit of a negative for them, became a positive, because from that moment onwards they knew exactly how to install, and they were, I would say, one of the best installers we have now, because they understand exactly how important it is to keep the spacing, to keep the MC4s off the ground, and to ensure that cables are not pinched and routed correctly. So they had a bit of a very steep learning curve, but they became a great ambassador for SolarEdge, and also a great installer of the product. So this is a question of modifying the optimizers. So you can't do that. You can't drill a hole, you can't bend it. These ones here, you can see in the middle, they've been used with an impact driver and bent it. Why do we say no impact driver? Well, it's an electronic piece of equipment. It is in a form of resin, so I understand it's not going to be a problem. It's in a big block of resin, so it shouldn't really come apart. But the fact of the vibration or swinging the optimizers around by the cable, that's going to cause a problem. That's not good. And this one here just completely bent up. Don't know what they did with this one, but that was completely bent. Maybe they tried to lift it up or bend it down, I don't know. And on the left here, you can see how the cable, the bolt has been screwed in from the other side, almost bending it, causing some stress to it. Again, we've got modifying optimizers, so don't drill holes in them. We've got a lovely hole here for you, lovely keyhole here for you. Don't do that, which was on here. The reason we want you to use the keyhole is you can then get the spacing. So if you're too close to the array, to the rail, you can just move the thing in a different place, slide it up with this bit, and that will give you your 10 mil clearance. Then we look at meters and CTs, okay? So I will comment on the electrical installation. I am a qualified electrician, so please don't shout at me for not knowing what I'm talking about. I have been an electrician since 1987, and then I became an electrical engineer, and I also taught at several different colleges and universities for all kinds of electrical related things, from wind turbines to nuclear to just general installation. So I do like to think I know what I'm talking about. I also had my own test and inspection company for 10 years, and that's what I specialized in, was inspection and testing. So we look on here, we can see that the left-hand picture here is showing a CT. One of the issues with this is the actual cable here. Now this is a big problem, because if you start making loops, it affects the actual reading that you get on the meter. So we don't want you to extend the CT at all, okay? Very, very much against that. But we are willing and we are happy for you, if you need to, reduce the cable length on the CT to do that. We'd rather have you cut the CT cable to suit than to have it curled up and have lots and lots of excess here. That's not good. On the other one, you can see what the earth cable sticking out here. We all know that should be put in a connector block. I don't think we need to argue about that. You've got the amount of cable here on the brown and white. We need to keep that as short as possible, very similar to when you connect Ethernet cables. Keep the shielding as high as possible. We've got some poor cable management. We've got our products installed. Nothing wrong with the products, but look at the way that the cable's just been hung. Nice bit of trunking there. Even a couple of clips, you know, that would be suitable. That would really help. And there was a clip here. As you can see, it's pulling a little bit too tight, so the cable's a bit short as well. And I'm sure those of you who install our batteries know that there is actually a entry exit point under here. So the cover wouldn't go on this. So again, that's not the product's fault. So we've also got some mounting issues. So batteries, they need 20 centimeters around them in all directions. Okay, we've managed to find a nice little corner here to put it in, but again, it's not 20 centimeters on this side, and it can affect the performance. Same for here. Inside a cupboard, 20 centimeters all side. And above, we also got the gap between the inverter and the battery as well. And don't forget, if you run trunking in or you put a box underneath, that also counts as an obstacle, and you need to then move the inverter further away or the battery further away. So these are some more examples of clearances. You can see the batteries are installed on the bottom. They need to be 20 centimeters away. The inverters are on top of each other with an AC isolator, so that isn't giving the breathing space that this needs for circulation of air here. And likewise, the trunking needs to be measured as an obstacle. So that battery needs to be 20 centimeters away from the top here. Again, a box over here. It might mean that you have to move some products around. It might mean you put the inverter here, and then you put the AC isolators below, or the AC isolators to the side of it, or stagger them. Put the AC isolator for this one here, put the inverter here, put the AC isolator for here, with the appropriate spacing. This is not the product fault. This is installation again, and it all affects the performance of the product. Then we've got some nice, correctly mounted. These are lifted up from the floor, 20 centimeters between. The inverter has a small bit of trunking there, which I would like people to take into account, because the amount of cables here does affect the airflow. And likewise outside, as long as that's a correct spacing above. This is obviously prior to PAS 63100 2024, because it's by a window. If the window itself was lockable and it didn't have these vents on it, that would be perfectly fine, because if the battery was to vent, it wouldn't be venting inside the home. So if the vents can be closed off and the window can be closed, you can install the battery there. Okay. And then on the AC side, just cables cut out. Okay, we don't need them, but as an apprentice, I was always taught if you had extra cables and you weren't using them, make them into an urn. That's what I did, and that's what I would have recommended if someone had asked me this question. The next one is comms faults. It's very difficult for SolarEdge to help you if you don't help yourself. So you've got to ensure that you put the installation in as per the guides. So you can see on here we've got a connection. Now the problem with the connection here is you haven't connected the sheathing together. So you see the shield there? So you should connect the shield together, and at one end, only one end, you should connect the shielding and the G together. So only at one end, okay? But here we haven't connected the shielding, so that's going to cause a problem. And we're using connections here, which is fine, but look at the distance we've got. So we've got possible interference here. Same one here, we haven't connected the shielding together, which again needs to be done to keep the cable together. We've got a long length of cable here between the actual connector block, and the same on this one. And the one at the bottom here is incredibly short. We've stripped the insulation so far back that we're pulling tight on it. So it's all about your designing, your preparation and planning. You've got to get it You've got to get it right. You've got to help us, basically. You can't expect us to solve problems if you're not going to help us. And then we've got on the left-hand side, we've got lots of connections. We've got an Ethernet connection here, along with an energy meter connection. And you know, you can imagine the amount of interference you're going to get between these devices. We need to keep it as simple as possible. A fixed terminal block would be acceptable, and keep the cables as short as possible. And then on the other side, where you've got, you haven't used the twisted pair, you've got a blue with white, you've got an orange with white, and you've got a green with white. What we should have in here is a blue with white, say, a blue in here, and a green on its own. And again, the cables themselves should be suitably terminated. That isn't really allowed, is it? This one here, again, the long length of cable, the cores cut off. There's nothing wrong with having the cores and wrapping the cores around and securing them. That's fine, because you might need, there might be a broken cable and you might need to use the blue and the white. And if you cut them off too short, well, that's not going to help. Again, the length of run here, and the fact it's not a twisted pair, so we've got a it could be a twisted pair. It could be brown and white, that one. Yeah, that's brown and white, and then brown. So we'll say that is a twisted pair, but that one isn't. Don't know what that one's doing there. And the green, you can still see the copper showing on there. And again, keep these cables as short as possible. Keep the sheathing should be all the way up to here. You know, a couple of centimeters at the most. Then we've got people that have trouble with the gland, and maybe the AC cable was a little bit tougher than what they thought it was. So rather than installing the gland, they've just left it open. Now, if you leave this open, what happens is the cool air will be sucked into the inverter, and it will condense inside the inverter, and then you'll have moisture all around the electronics, all around the power board, the communication board, the digital board. You may have a LTE in there for communication. This is going to affect the product. That is not the fault of the product, that is the installation again. None of these faults that you will get from the slides today are a fault of the product. They are the fault of the designing, the installation. You know, I can't really say much more than that. So, without safety C or arc fault circuit interruption, there will still be enough of an arc to cause a fire. You can see on here, this is a video. I just took a still from the video. It is on fire. Okay. There's no DC isolator here. So if you then have to go and repair this fault, obviously the cables are going to be destroyed. The inverter is going to be destroyed. You're going to have live cables on those red and black cables there coming out the bottom. These are going to be live until it goes nighttime. And then in the morning, when the sun comes up, they're going to be live again. This is why it's really important to have DC isolators on, I would say, on non-solar edge products. And people will argue about that. But with solar edge, as I said, turn the toggle switch off, turn the AC off. If you cut the cable, if there's an arc on parallel, or if there's an arc on series, if there's a communication issue, it will go off. You will not get this with solar edge. Okay, you will not get these fires with solar edge. Okay, nearly at the very end. So how can you help with this? This is what we want you to do. We want you to help. There's a QR code on the screen. You can scan this QR code. What we've basically done, we've teamed up with BRE and some other manufacturers, leading manufacturers in the industry, and we're going to do another research product based on the 2017 research product. And I want you to tell us what you see on site, because what happens is you will only see reported worst case scenarios. So when I was in the nuclear industry, we had this saying of near hit. It wasn't a near miss, it was a near hit. So if someone fell off a pair of steps, well, that was classed as a near hit because he nearly hurt himself or he nearly fell off those steps, not a miss. So on this survey will be things like, are you seeing MC4s that are the wrong kind? Are you seeing them badly installed? Are you seeing issues with clearance? Are you seeing DC isolators? So you're the ones that see this, and what happens is you get called out as an installer, you go to a site and you just repair the stuff. You give the customer an invoice, you say, tut, 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 it shouldn't happen like that, and you know, we need to do, the industry's rubbish and these other installers are rubbish, but we're brilliant and we will rectify it, we'll get it working for you. So what we want you to do is we want you to tell us of all those things that you see, not individually, but if you are seeing them, when are you seeing them? Why are you seeing them? Is it because people are using the wrong tools? They're not crimping, they're not using a tape measure, they don't have the training? Just feedback these things for us, and we will put them together. We'll go to the BRE, we'll talk to the other manufacturers that are in the BRE on this particular thing, and we'll say these are the sorts of things that we're still having from 2017. Nothing has changed. You know, what can we do to make it better? So I need your help. SolarEdge needs your help. Everybody needs your help. So please scan this QR code. So thank you very much.